Okay. So we did a bunch of just kind of jumping around on 1, 2, and then on Friday with that short class, I just wanted to make sure that we had enough to get the homework done. Lucky you guys though, we are not gonna get enough of 1, 3 done to do any homework tonight, so we get the night off. How fun is that? Pretty fun. We are looking at a quiz on Friday though. I do not see you tomorrow because it's service day, but I will see you Thursday and Friday. I think everything that we learned up through today is fair game for the quiz, and then we'll talk more about that on Thursday, but nothing we learn on Thursday should be on the quiz. Okay, so let's go look at number 3. It's a lot like number 2, and it's a lot like the one we just did on our homework. So we're still considering this graph. It's part of a parent graph. Do you know which parent graph we come from for this? The parabola, good, our squaring or our quadratic. So it's going to be a parabola. Is it going to be upwards or downwards?
Yeah.
Why?
The X.
The X is negative. Good, and then what does that 3 do to our graph?
Moves it right.
Not left. Not down. You're like, we just nailed all the way around it. We finally found it in the middle. Think of it like if I had negative x squared plus 3, that plus 3 is being attached to the end. So we're going to go up 3 units, 1, 2, 3, and then we're going to graph an upward or upside down parabola from there. I don't really need it to be super exact. That's good enough. And then once we've graphed it, we're going to answer all of these questions that we've gotten used to answering. So is it continuous? Yes. All right, increasing, decreasing. As I start, what am I doing?
Increasing.
I think we're increasing until x equals what? X is going to be 0, y is 3. So we'll care about that in a little bit. But when I'm doing increasing and decreasing, I only care about the x's. So I'm going to start and say I'm increasing from negative infinity all the way up to 0. We're increasing until we get to 0. And then once we hit 0, then we start decreasing. And we decrease from 0 to what? Good. Negative infinity. Positive infinity. Did I say negative? Thank you so much. Positive infinity. All right. When I get to the next one, it says bounded above, below, or bounded. Where is it bounded at? It's bounded at 3. Is it bounded above or below at 3? Above. There's like a line above that we can never go. There's a ceiling that we can never go above. So we have to stay below it. We are bounded above. And you can write at y equals 3, or you don't have to. If that makes you happy, we can say that. Any asymptotes here? Great question. It's kind of you have them or you don't. When I have a squaring function, whenever I have a parabola, there are just no asymptotes. So it's kind of getting into the mindset of what are asymptotes, and that's something we're going to explore a little bit more next class. Like reciprocals always have asymptotes, exponential have horizontal asymptotes, natural logs have vertical asymptotes, but like cubics, absolute values, quadratics, they do not have asymptotes. So I have none here. You can also see if we're like rapidly approaching something, we're not really approaching something and then never crossing it. So no asymptotes. Any maxes or mins? Yeah. Good. At 0, 3, we've got a max. Now, question for you, is this an absolute max, a local max, or both? It is an absolute because it's the highest of the whole graph. Is it also higher of the highest of the ones around it? Yes. So this one's both. It's both a local and an absolute max. And I might write that both local and absolute. I am not necessarily going to test you on is this a local or an absolute max. I just wanted to start getting into your vocabulary and you starting to feel comfortable with it. Okay. Is there symmetry here?
Yes.
Yes. Do you believe it's even or odd symmetry? Even. When it's an exact reflection of itself, that's even. And we're going to deal with some more symmetry today. What's my domain? All reals, good. Negative infinity to positive infinity. What about my range? Not all reals. Would you say? I think we're just looking at these y's down here. So what's the highest y we can get to? 3. And then everything below it is fair game. So we're gonna go negative infinity to 3, and we're just gonna put a bracket with that 3. And then zeros, we're gonna go to the calculator to find our zeros here. This wasn't a nice, easy one for us to find normally. So let's go to our calculator, plug your equation in, and let's find our zeros from there. Come back. So I'll put 3 minus x squared. You may have a stat plot still highlighted, so make sure it's not highlighted if it is highlighted. And then I'm just gonna go to my normal window, so I'm gonna go zoom and then standard. Whoa. That's not at all what I want. Okay. That was very odd. I'm not sure what was going on. Now from here, I'm gonna find my 0, second trace 0. Does anybody need any help with what's going on in their graph? Let me know. Sometimes because we're playing around with different stuff, when you try and do something normal, sometimes it doesn't do it. So just let me know. So I've got negative 1.7. And then we've got positive 1.7. All right, how are we doing? Good? Okay, let's flip our paper over. We were just talking about symmetry. Let's explore symmetry a little bit more. We're going to do it algebraically. You don't need your calculator for this. So this next part is just symmetry. So that's what I mean when I'm talking about even and odd. I'm talking about the symmetry of a graph or of an equation. I like to remind us that whenever we're thinking about even symmetry, that is the one that's the reflection. So if I were to draw like a little picture of it, a parabola is a good example of it, an absolute value is a good example of it. And so I'm just gonna parabola so I have like a nice pretty picture to describe what I'm doing. Odd, I wish I had a cuter way of explaining it like I do reflection. Odd is just the same in quadrant 1 and quadrant 3. So same in Q1 and Q3. So a good example of that is a cubic function. Goes up and through, something like that. Greatest integer, I don't think it technically works because of the open versus closed circles.
So it would also be like if it's in quadrant 2.
Yes. But generally, it will be in quadrant 1 and 3 unless it's a negative of a function, and then it could be in 2 and 4. They might just have none, and that's an okay thing to do. Okay, so if we have symmetry, it's either a reflection or it's odd, which means it's the same in quadrant 1 and 3. Okay, when we're thinking about symmetry and I'm doing it algebraically, we're gonna worry about the positive x values and the negative x values. So if I go look at this graph, if I come look at like this positive x value up here and it's negative x, like the exact same number but negative on the other side, they should have the exact same y value. They should both have the same y value on the graph. That makes sense, right? If they're exact reflections of each other, whatever like 2 is, negative 2 should also be, right? We feel okay about that? Okay, what that means algebraically, what that means when we plug things in. For every x, for all x, all of my x's, the following is true for an even symmetry. F of negative x is the same as f of x. When I plug in the negative value into my function and it's even, it should be the exact same. So if I thought about like 2x squared, if I plugged a negative x in there, what's negative x squared? positive x squared x, right? Negative x squared is just gonna be positive x squared. Is that the same thing as what we started with? Yes, so that's how we go even. When we have a positive number in, it's the same thing as when I put that negative number in, okay? And we call this specifically symmetry about the y-axis. Or symmetric about, bless you, the y-axis. Okay, the odd symmetry is a little bit different. And this time for all of my x's, when I do f of negative x, it's not the exact same as f of x. It's going to be the negative version of f of x. Okay, let's look at a graph for that. When I plug in negative x for my even, it just stays the same. When I plug in negative x in for my odd, the whole function goes negative. That's the odd one. So if I go look at my odd graph, let's go look at it over here. Let's say I've got an x value right here and it has a y up here. And then I have my negative x over here. It corresponds to that same y value, but it's now the negative of that y. Does that make sense? So it's the same number. Like if I plugged in a 2 here, I would get out 8. If I plugged in a negative 2, I would get out negative 8. So it's the same number value, it's just got a negative in front. Okay, if I were to think about that algebraically, let's say I would have like 3x to the third. What if I did 3 times negative x to the third? When you raise negative x to the third, will that number be positive or negative? Negative. Whenever you raise it to an odd power, it's going to stay negative. So that becomes a negative 3x to the third. Is that the exact same as what we started with? Almost. See how this was positive and this is negative? That is the major difference. So when I plugged that negative in, I ended up getting negative of the whole function. Okay. And when we do our odd symmetry, it's what we call symmetric about the origin, which is kind of a hard thing to draw. But I want you to know it's not the x-axis, it's not the opposite of the reflection, it is symmetric about the origin. It's something a little bit different, it's something a little weirder. Okay. I know we still haven't done 6 and 7, but number 8 is a lot like this. So we're gonna go jump to number 8 so we can do this same idea. Okay. So number 8 says even, odd, or neither, and this is more of our symmetry. If we look at this first one, it says f of x equals x to the fourth, okay? Whenever we do this, we are going to plug negative x in to our equation, and we're gonna see what happens. Every single time we're gonna plug negative x in and we're gonna see what happens. So in this first one, I'm gonna take negative x to the fourth. When I raise negative x to the fourth, will that end up being positive or negative? Positive, good. When we raise it to an even number, it's going to go positive. So then that just takes me back to x to the fourth. How does that relate to what I started with? Is it the same?
Yeah.
Good. Was that even or odd? Even, good. So this one has even symmetry. Let's look at the next one. Same idea. Let's plug negative x in. So I've got square root of negative x squared plus 2. Okay. When I square negative x, what is that going to be? It's going to be x squared, positive x squared. So now I've still got this radical. I've got x squared plus 2. Can I simplify that anymore? No. How does that relate to how we started? Same. So what am I, even or odd? Even. Very good. Okay. Now let's do the next one. It says 2x to the third minus 3x. We are going to plug negative x in every time you see an x. So two times negative x to the third, what's that gonna end up being? Negative x to the third will be positive or negative? Negative, so that will become negative 2x to the third, and what about negative 3 times negative x? Plus 3x, okay. Can I simplify any more? Nope. How does this relate to what we started with? It's the exact opposite, right? See how I had a plus 2x to the third and now I've got a negative. I had a minus 3x and now I have a plus. Everything is the exact opposite sign. So that means it is odd. Okay. Next one, it's got 1 over x. I'm going to make that 1 over negative x. Can I simplify that anymore? No, that's as good as it gets. How does that relate to how we started? It's the opposite, which makes it odd. Very good. So that was positive, now it's negative, so it's just odd. Okay, and then we've got this last one. I've got negative x squared plus 0.03x plus 5. And again, every time you see an x, make it negative. So I've got negative of negative x squared plus 0.03 times negative x plus 5. Okay, negative x squared is going to be positive, but I still have that negative out front, so it will stay as negative x squared. Everybody okay with that? It's almost like too many negatives, but I think we figured it out. And then 0.03 times negative x will go negative. And then plus 5, no, that'll say plus 5. Okay, how does this relate to how we started? Only some things changed, right? Not everything changed. See, the negative x, the x squared was the same, and the plus 5 was the same, but that middle one changed. It didn't all stay the same, and it didn't all change, so this is just a none. There's a lot of things that have no symmetry, so sometimes when we're focused on symmetry, we're like, what do you mean there's no such thing? It's a none. It's because not everything has symmetry, and this one just will not have it. Okay. All right, we skipped 6 and 7, so let's go back up there so that we can finish our 1.2 notes. That's kind of it on symmetry for right now. Are we feeling okay about that? Okay, just plug in that negative x and we'll see what happens. Okay. Jumping to this next part, we've got vertical line test. Is it a function? We know vertical line test. Is this first one a function? Yeah, perfect.
Yeah.
What about B? No, good. Oh shoot, those first two were really easy because there were pictures and now there are no pictures. When I get to C, let's get y by itself before we decide anything. So when I get y alone, what do I need to do? Square root. When I add my own square root, what do I need to also bring with it? Say it louder. Plus or minus, very good. So it becomes y equals plus or minus square root of x plus 2. Okay, that means when I plug a number in for x, I have to do the plus and I have to do the minus of it. So if I plug like 0 in for x here, that means it's going to be plus or minus root 2. I could get the answer positive root 2, or I could get the answer negative root 2. Is this 1-to-1? For the one x I plugged in, did I just get one y? No, I got two y's, didn't I? Technically, this is a sideways parabola. The reason a square root function by itself is a function is because it's not plus or minus. On our BFF graph, our square root was just like the top half of that parabola. Because we had to put in that square root, we had to bring that plus or minus with us, and that's what made it bring the bottom half of that graph, which when we make that a vertical line test, that does not pass. So this one, if you have a y squared ever, it is not a function. No. Okay. When I look at letter D, again, you can get y by itself. You can add y to both sides minus x from both sides. When we do that though, oh, sorry. We end up getting y equals negative x plus 12. Does that look like a normal function? That one is fine. There's no squares on the y. We can plug one number in for x, and we're just going to do that number negative plus 12, and then we're going to get our y up. So that one is fine. That one's a yes. Okay. All right, cool. So those are whether they're functions or not. Let's move into types of discontinuity. I'm gonna preface this and say, I'm never gonna ask you to like memorize these types of discontinuity, but let's just practice looking at the difference of them, okay? So there's removable, where I literally had one point that I just took out, everything else on the graph was normal. We had jump discontinuity, where we took like part of the graph and moved it upwards. And then we have non-removable, which just kind of looks like a reciprocal graph, okay? So we're gonna sketch a little graph of these two, and we're gonna decide whether it's removable jump or non-removable discontinuity, okay? Now, before I get going on letter A, can you simplify this at all? Can we make this easier to look at? What can I take out of everything? An X, good, since there's an X on the bottom, I can take an X out of everything. So I get X squared plus 1. Oh, shoot, that's gonna be easy to graph, right? X squared plus 1, it's just a parabola. What does that plus 1 do to my graph? Brings it up 1, good. So let's go just do a little sketch of that graph. Okay, now, one issue that I have here is, remember how I asked you if we could simplify and we took an X out of everything? Remember also yesterday when we were doing domain, or however many days ago we were doing domain, and we said that one of our problems was our denominator cannot equal what? 0. I know we got rid of him, but he was part of the original equation. So we still have to set our denominator not equal to 0 to have a break in our graph. So even though we canceled him out, he still means that we cannot plug 0 into this equation. So that means there's gonna be a hole at 0. There's gonna be a hole right there at the like minimum of my graph, at that vertex of my parabola. We're gonna have a hole there. If I just have a hole and everything else looks normal, what kind of discontinuity is that? Removable, very good. Removable. I don't know if that E is in there, but it looks like it's here. Sorry, spelling is not my strong point. Okay, removable. Okay, that's all that we were looking for there. We were able to do a removable. Let's look at the next one. Can we simplify anything here on B? Yeah, what can we simplify? We don't have an X over here. So we can't simplify the X's. We could, it's not gonna help us make it simpler.
Yeah,
Yeah, what?
we can.
Yeah, we can simplify it.
I mean, I'm sorry, we cannot.
We cannot simplify it. Yeah, I would agree with that. We cannot simplify this as much as I want to. The last one, we had an X and everything. That's why we could simplify. We don't have an X and everything here, okay? That means this looks like one of our reciprocal functions, right? This looks like the parent graph of 1 over X. Can we find our vertical asymptote and our horizontal asymptote so we can make a sketch of this? What's my vertical asymptote gonna be? 2, very good. What did you do to find 2? Good, we set the denominator equal to 0 because that would be the problem. That would be part of our domain that's missing. What about my horizontal asymptote? 1, how'd you get that? Good, since the exponents are the same, we look at a fraction of the leading coefficients, it's gonna be 1 over 1. Okay, so we're gonna sketch our graph, as long as we have our asymptotes in those 2 places. 2. Oh, what am I doing here? 1. And then we just kind of do our little C curve in the first and third quadrant. I don't really care about any specific points at this point. Is this removable jump or non-removable discontinuity? Non-removable, very good. All right, I think now we have finished our 1.2 notes. How we doing? Good? Okay. We're gonna jump in and, is this on the quiz?
Yeah.
No. No, I did not put this. I think a minute ago I said I would not ask you this kind of stuff. I would never ask you about removable or non-removable. There's certain things that I'm not gonna test you on, but I need to like show you the differences. So that's, I wouldn't test you on.
Our BFF graph's gonna be on. our
Yes, great question. BFFs will still be on your test. So that is something to remember. All right, let's jump in because the next part we're gonna do will also be on your test. So I wanna make sure that we get at least all through this. And then I had a couple of graphing problems, but we'll get to those if we can. Okay. If you skip all the way, we'll go past all your BFFs. We're back into 1.3 now. And it says sketch. So we are starting some transformations here, okay? We're gonna do more transformations later in the chapter, but we're just doing some very basic transformations of BFF graphs right now. So since we're talking about transformations, I want to give you like the basis of all of the pieces of what can happen. If you notice, we're primarily adding or subtracting with the x or on the end of our equation, and every so often we have a negative. So I'm going to explain to you a few things that we're not even going to look at yet, but we will look at in the upcoming days, weeks, whatever. So whenever I like to do transformations, I always start at the very beginning, okay? I think about, we're looking at the f of x is like our general function. From that, there are 4 things that we can add to change that graph. We can have something in front of my function, multiplied by all of it. I can have something that's being multiplied by my x. I can have something being added or subtracted to my x. And I can have something being added or subtracted to the end. So I label those A, B, C, and D because those have different meanings in different places. We'll start with the ones that we are doing the most with. What if I'm adding or subtracting something to the end of my function? What if I have like ln of x minus 2 or x squared plus 1? What does that do to my graph? Good, it brings it up and down. So it's my vertical change. So I'm going to say it's an up or down shift. And it's what you think it should do. If it's plus 1, you move it up 1. If it's minus 1, you go down 1. So I like to remind myself it's what I think it should do. Okay. Now, what if I have something inside my parentheses with my x? Like over here, I've got x minus 2, which is inside that x squared parentheses. How does that move my graph? Left and right, it moves it horizontally. Now this one though, it moves it opposite of what you think it should do. So if it's minus, it actually goes to the right. And if it's plus, it goes to the left. In my head, and maybe you in your head, you think differently, but in my head, right should be a plus sign and left should be negative. It's opposite of what I think. So the minus means that we're going to go to the right. The plus means we're going to go to the left. Okay. That's primarily what we're dealing with today. However, let me explain a couple other of these things. If I have something being multiplied by my x, so like let's say I have like a 2 right here in that parentheses, or like a 1/2, like parentheses 1/2 x minus 2. If I have a number in front of that, that's going to make a horizontal stretch or shrink. So it's going to either stretch horizontally or shrink horizontally. We're gonna do a lot more with B's like later in the year. That's not a new thing. But A's we might be able to do things with, yeah. Can you say that one more time? The X is just the variable. So just the B. Yep, if there's a number in front of your X, that's your B. And then if you have a number in front of all of it, then that's your A. And that does a vertical stretch or shrink. And again, we will look more at that later, but if you have a number out front, it's like multiplying your whole function by 2 or by 3 or by 1/2. So we're going to be multiplying all of the y's by a certain number. We're stretching it this way. Again, if you look at the problems that we're about to do, most of them are just C's and D's. The only thing that I do have with the A is if I have a negative. What happens if you have a negative in front of your function? What does that do? It flips it. Good. So it's going to flip it. If you see a negative, we're going to flip. Okay. Now, if you notice, all of these are BFFs, so it was really important for us to know what the BFFs were before we start doing this, because we can't do transformations if we don't know what to graph. So we're gonna take these graphs and we're going to move them like we need to, and then we're just gonna sketch our BFF. So if I look at this first one, what graph is that gonna be? Absolute value. What does that +1 do to my graph? Goes left 1. So I'm gonna take my V, my absolute value, and I'm just gonna move it left 1. So I'm gonna come over 1 and I'm gonna do my V from there. Doing okay with that? All right, what about the next one? X minus 2 squared. What graph am I gonna do? Squaring, parabola, quadratic, and then what does that -2 do to it? Right 2, good. So take your parabola and scoot it right 2 units. If it makes you happy, you can label your graph, like I put -1, I put 2, all that fun stuff. But you don't have to if that doesn't make you happy. I like to explain so that you know that I know what I'm doing. With this next one, it says ln of x minus 2. Some of us, not a lot, some of us wrote in on the quiz. It's not in, it's ln. It's usually like a cursive ln for natural log. So if you weren't sure what that is, that's an ln for natural log. Do you remember what the natural log graph looks like? It's kind of like a little funny thing like that. Now I'm gonna do -2 to that. What is that gonna do to my graph? So it's not in parentheses with the x, it's by itself. It's gonna go down 2. Negative, when it's on the outside, it does exactly what you think it should. If it looked like this, see how I threw some parentheses around it? That's when you go left and right, but there are no parentheses there. So I'm assuming that -2 is just attached to the end. When I take this graph and move it down 2 units, basically, I'm just gonna go, well, let me get all of the graph in here, just down 1, 2. It's basically the same graph, just a little bit lower of a slope. We're not going as high to begin with. We're kind of going a little bit lower, but it will go above the x-axis eventually. And you could even write -2 on the y-axis so that you know it went down 2. All right, what about the next one? Reciprocal, what does this negative do? Flip. If my reciprocal is normally in 1 and 3, how does it flip it? 2 and 4, very good. All right, what's my next graph? Square root, what does that look like? Right, and then what does that +1 do to it? It's gonna move it up. Notice how the square root ends over the x. If it extended all the way over that +1, then we'd be moving right or left. But since it stays just over the x, we're gonna move up 1 unit and we're gonna juke from there. All right, x minus 2 to the 3rd. What's cubic? Good. -2 does what? Right 2. Good. So I'm just gonna kind of snake through my graph over there on 2 instead of on 0. Am I going too fast? Okay. The next one says sine of x plus 2. Okay, remind me, where does sine go through? What's the one point that I want you to know where sine goes through? 0, 0, very good. So normally it goes through 0, 0, and it just waves up and down. Normally it waves from what to what?
Down.
What are the two like bounds of it? 1 and then -1. We're gonna know that a lot more closer later. I don't really need you to know that yet. I really just need you to know it goes through 0, 0. But it does technically go through -1 to +1. Okay, what does this +2 do to my graph? Up 2. So I'm gonna move up 2. So instead of going through 0, 0, it's gonna go through 0, 2. Now, instead of my bounds being at -1, 1, where are my bounds gonna be now? We gotta move everything up 2. So instead of being at -1, move that up 2. What am I at? 3 and 1. Good. -1 is gonna move up to 1. 1 is gonna move up to 3. Now, what some of you guys were doing when you told me -2 and 2, that's if I had a 2 out in front of the whole thing. That's if I had an A value of 2. We don't have that. Instead, I still just want my sign to kind of wave back and forth up here. It's gonna go as high as 3 and as low as 1. Yeah, Chase.
What's the difference between sign and cosine on a graph?
Great question. Sine, don't draw this on your picture, but sine goes through the point 0, 0. And it waves, and then cosine goes through the point 1, 0, and it also waves.
Okay.
They are the same graph with a horizontal shift. And when we get more into sine and cosine, we'll talk more about them. They are basically the same graph. If I could just pick this up and move it over, see how they match up. That's done intentionally. Millie.
I'm a little bit confused on like how does. So when it goes X plus 2,
Mhm.
how do you know that's going? Up to instead of, why isn't it going left to right? Because on like A,
Mhm.
no, not A. Oh, never mind. I figured it out,
What did you figure out?
that's an absolute value, so it switches.
Do you also notice that like in this first one, it's inside the absolute value? And in the one next to it, it's inside of that parentheses. Since they have parentheses, I know it goes with the X. If there's no parentheses, we just assume it's attached to the end. That is a really great question. So if I look at this next one, what is this -1 gonna do to my graph? What'd you say? Go down, down 1. Now it's an exponential graph. What does that look like? Do you remember what our exponential graph is? It's kind of flat and then it pops up. So if I'm gonna go down 1, normally it doesn't cross 0. Now it's not gonna cross like -1. So -1, you can think about there being that horizontal asymptote, and we can't cross that. So we're gonna go here. All right, and then in I've got, what kind of graph here? Absolute value. What does that negative do? Flip it. So I'm gonna make it an upside down V. Okay. All right, I wanted to get farther. We got a little farther in the last class, but we'll catch up tomorrow. We just have a little bit of calculator stuff to get through. But I really wanted to get through this stuff. You have no homework. If you want to start 1.3, great. I will probably not assign that till Thursday, okay?